There we go, that's how it works. So, hi everybody. I'm Steve Boltuck, and this is SID327, how Zocdoc achieves security and compliance at scale with infrastructure as code on AWS. And I'm here with Zhen and Brian from Zocdoc. I'm just going to be doing an introduction, so I'm not on stage very long, so you don't have to deal with me. But I've been working with Zocdoc for about 2 years now, and when I first started working with them, they had everything running on-prem. They didn't use AWS. They had a lot of security concerns about AWS, which is why this is really relevant for our audience here. The initial conversations were focused on security and understanding how they would be affected by our shared security model and how it would affect everybody for them and their downstream BAAs. They are a healthcare company. They do have to worry about HIPAA and PHI. We met with them for many, many meetings, going through contracts, going through their security and compliance requirements, redlining things, and making sure that everything was understood so that they knew how to posture themselves to their customers. As we talked more, Zocdoc started to leverage AWS as a trusted advisor. They talked with us more about how their business should operate in the cloud and how they could grow their business on AWS. Not just on security, but general best practices. They talked to us about serverless operations. Should they be using things like NoSQL? Should they be using Lambda? Should they be using API Gateway? How would that affect their business, and how could that affect their customers and things that they wanted to develop? They hosted hackathons internally to evangelize the use of AWS. They did dev talks where they had me come in and other SAs and team members to present to their team. And along the entire way, they worked very closely with us, and that's something that they're going to be talking about today, how they partnered with AWS to really help influence our services and allow us to help influence how their technology was going to change on AWS. So with that, I'm happy to be here to introduce them, to show that how in a little bit less than 2 years, they've gone from 100% on-prem to now 100% on AWS, improving security and moving faster and iterating and really building a great product for their customers. And I'm happy to have been a part of it. So I'm going to pass this off to Brian, and he will talk to you about, well, if I can find the right button, about what Zocdoc is doing today.
Great. Thank you, Steve. I appreciate it. Good afternoon. My name is Brian Lazada. I'm the Chief Information Security Officer for Zocdoc. And we're going to talk about our journey to the cloud. But first, I want to talk about a little bit about what Zocdoc is. Zocdoc is a New York-based startup where 6 million patients visit us every month to book their doctor's appointments. And if you look at the average US patient, it takes them about 24 days to actually get into the doctor's office. But there's a lot of hidden availability that doctors don't put out there. And Zocdoc's able to actually do that. There's about 30% of unbooked, canceled, and rescheduled appointments that is not available to patients. But we at Zocdoc, we're able to actually bring that to our patients. We bring marketplace efficiencies. So what Hotels.com and Kayak do for the travel industry and OpenTable does for restaurants, we do for healthcare. We're actually able to bring those 24 days down to 24 hours. And that is a huge, dramatic drop, and it helps our patients get to their care a lot quicker. We started our supply of care back in 2007. And if you look, we started by going after local doctors and local practices. And we optimized our technology for that use case. But as we began to grow and we gained critical mass, we figured that our architecture was not going to be able to handle that. We started partnering with large health systems. These large health systems had the same concept. They wanted to bring more patients into their health system, and they wanted us to help them with doing that. And we knew that our architecture was not going to be able to support that. So we wanted to go through some digital transformation, and we decided that Zocdoc 2.0 in 2016 was going to be our focus, and partnering with AWS was going to be our main priority for 2016. Some of our goals with going to AWS was we wanted the ability to scale horizontally. We wanted to be able to meet our patient need and our health system need as we continue to grow our business. We also wanted to diversify our tech stack. We wanted to be able to leverage new and emerging technologies. Right? We wanted to take advantage of open source technology, which gives us the ability to develop products a lot quicker and not have so many roadblocks. Data liberation. It's very important for us. We want to be able to use our data to continue to innovate and drive more products for our patients. And selfishly, I wanted to elevate security when we were doing our migration. So I'm happy to report that in 2016, we came up with the concept of Zocdoc 2.0, and here we are in less than 12 months, and we are 100% in AWS. Some of my top typical concerns when it came to the migration for security, first one was maintaining compliance. As you heard, we get 6 million patients that visit us every month. That number is going to increase as we continue to grow. But I wanted to ensure that we were able to maintain our HIPAA compliance. So I wanted to know how we were going to be able to do that when it came to migrating our entire infrastructure to the cloud. Second thing was shared responsibility model. When you're using AWS, and you have to understand that model of where your responsibility begins and where AWS responsibility begins. This shared responsibility model is going to drive how you architect your environment, how you maintain your environment, and how you do incident response. It's incredibly important to understand this model. Next thing was maintaining visibility. We wanted to maintain end-to-end visibility of our entire data. From the moment the patient injects it to the moment it's actually stored, we needed to have that in total visibility, and I wanted to maintain that going into AWS. Next thing was access controls. On an on-prem model, you know that access controls get inherited and things just get lost. So this was a great opportunity when we were moving to actually control our access controls and get more granular with what our users and services were doing with our patient data. Next thing was encryption and key management. Data protection is obviously incredibly important for us, so I wanted to ensure that we were taking care of our data and they were rotating keys appropriately. Next thing was logging and monitoring. So I wanted to ensure that we had the logging capability and monitoring of our environment. Being a CISO, you're always thinking about prepare for, respond to, and recover from an incident. When something does happen, the first place you go is logging. You have to go to your logs to actually see what's going on, to either recreate the incident or do some sort of forensics. So I wanted to be able to have that while we were migrating over to AWS. And the last thing was, being a CISO, I always have that feeling of impending doom. I wanted to understand how we were going to do incident response, right? How we were going to do it with not having an on-prem model, solely partnering with AWS. So first thing was maintaining compliance. We did a lot of diligence in looking at some of the services that AWS offers, and they actually have services that already have compliance baked into it. They have so many compliant services that we couldn't even fit them on the slide. In our case, it was HIPAA. We needed to see all the services that they offer, and that's what we were going to build our architecture on. We were going to take advantage of all of those services and start building and migrating our platform to those HIPAA-eligible services. Next thing, the shared responsibility model. AWS does a great job breaking down this shared responsibility model so that we know, one, how we're going to architect things, where our responsibility lies, where their responsibility lies, but where I could start my incident response, where I know where my responsibility is for an incident, or even operationally, right? They give us the infrastructure, but that data and application we put on top of that, that is our responsibility. So making that operational controls and incident response controls of that is clearly laid out in this shared responsibility model. I recommend for all of those of you that are either migrating to AWS now or in there, study this shared responsibility model. It really helps drive a lot of your operational controls. Alliances. Very important to have alliances when you're doing a migration like we did. First thing was we needed to have that strong partnership with AWS. And as Steve introduced us, he helped us at every single step of the way with that journey. We needed to have this alliance with AWS. Partnerships are very important. It helped us with business enablement so that we can continue to grow and actually architect our environment thinking ahead of what we were going to do with our business and generating and creating new products, right? Next thing was technical enablement, right? We didn't want to be restricted into the box of a data center or a server, right? Next thing was alliances internally within Zocdoc. Me being the CISO, I needed to have a very, very strong relationship with our head of infrastructure, Zhen which without that partnership and without that ability to actually communicate and collectively come up with this architecture from a requirements and delivery perspective, we would not have been able to operate so quickly and migrate so quickly. So I am now going to pass it on to our head of infrastructure, Zhen.
Thank you, Brian. So let's cover kind of the tech side of things. So Brian talked about compliance and how we're going to have shared responsibility model. So what about on the tech side? How do we make sure that we're secure on the tech side as we move into AWS? So we thought, let's break it out into a few layers, right? Security is not one thing that you do. It's something that everybody does, as Werner talked about during the keynote today. So we broke it down into these layers. So we wanted to maintain visibility. We wanted access controls, right, to make sure we knew how to lock down the permissions. We wanted encryption and key management because data has to be secure. We wanted logging and monitoring to make sure all our stuff can be auditable and findable if there actually is an issue. And of course, instant response, that we're prepared, that we know what to do in case something actually happens. So Brian, why don't you walk us through kind of the details of these things?
Great. Thank you, Zhen. When Zhen came to me and he said, Brian, this is going to be easier with AWS, I was like, wait, you're saying things are going to be easier as we migrate. So I wanted to give him a little bit more requirements or details on what I was exactly looking for. So the first one was maintaining visibility and control with agility. Look, the point of us actually moving to AWS, we wanted to maintain our agility, develop, create products quickly. So I wanted to be able to do that, but maintain visibility. All of our critical data, end to end, I wanted to see where it was going, who was touching it, who had access, wanted to maintain that visibility. The next thing was scope reduction. When you have bare metal technology or data center, you're in the data center, you will accumulate a lot of technology or a lot of data that sometimes you don't need. So this was a great opportunity to reduce our scope and reduce our threat vector by not migrating that and getting rid of it, right? So I wanted that to be part of the requirements for our migration. The next thing was enhanced alerting. I wanted alerting through our entire tech stack. If you look at information security or the industry as a whole, it was really designed to put things at the edge, at the infrastructure. Look, the edge doesn't exist anymore, right? Perimeter doesn't exist anymore. So I wanted alerting at each single level of our tech stack. And I wanted to make it a requirement during the migration. And the last thing was standardized configuration. You hear a lot of horror stories out there, S3 buckets left unencrypted. So I was like, Zhen, how are we going to prevent that from happening to us and giving us a black eye publicly and impacting our patients? Zhen?
So, large list of things to do. I mean, how many of you have had on-prem systems where someone rolled out the system by hand and wow, you have to go back in and figure out, okay, what did this person do? I have no idea how this was built, and now we're facing some critical issue. I have no idea how to reproduce it. So that's definitely something we felt as well, just like everybody else with the on-prem systems. But we decided, okay, if we're going to move to AWS, we have to do this correct, right? Let's do it right from the get-go so that we can reproduce everything. So we start at the very basic level, which is the OS level. And so with that, we start with infrastructure hardening. So what does hardening mean? Hardening means that you lock down the system, you know exactly where it's going to run ahead of time, and that it's basically untouchable. It's an immutable object. So with that, AMI has this feature called AMIs, right, which are a base image, and we harden them. We harden them by making sure that if you have a Windows OS, you have a Linux OS, these are the base images that you start with. And with that starting image, you have all these things built in. You have Packer, which allows us to apply patchings or additional software that the OS needs at the base level for everybody. Logging agents. So these are individual agents that has logging built in. So you can get metrics for all the pieces, how your hardware is actually performing on top of CloudWatch. Host-based intrusion detection. So this is software that we bundle in to make sure that we get alerted, that simplified alerting model, right? We get visibility when any host gets kind of intruded upon. And of course, antivirus, right? How many people have to maintain antivirus on their systems and worry, shoot, did I forget to install that? So we're trying to prevent all kind of home manual rolling of machines. Instead, it's all built in. It's prepackaged, and you know that every single system will have this. On top of that, as we moved to AWS, we also thought, OK, Zocdoc 2.0, how do we also get more agile? So we went with containers. And so with Docker containers, you also have this hardening that you must do. Right? At the host level, once again, you're using a hardened AMI. You want to make sure that that image has all these things pre-built in at the host level. But then with the containers themselves, we harden those as well. There's no one going in and manually changing anything with the container once it's in production. Instead, we have continuous integration, continuous testing system that goes in, devs make their changes in source code, right? They commit it to GitHub, runs through our CI pipeline, which brings the package directly up into production once it passes testing. That way, no dev actually has access to the container in prod outside of redeploying a hardened container that they've already pre-tested. This gives a lot of confidence in our systems, right? So that's only the base layer. What about the next layer? And that's the infrastructure as code. I'm sure a lot of you have been beaten over head about with infrastructure as code and what it means. So what it meant for Zocdoc was we had to pick a technology to basically be that kind of skeleton as code that we're going to run on top of these hardened AMIs and hardened containers. And so we went with AWS CloudFormation. Of course, that's built in with AWS. You get that for free. And then the problem with CloudFormation is every template would be kind of fairly specific to the server that you're building, right? Because if you name something as X name, you'd have to repeat that for every single server that you're rolling with that name. So we need a way of kind of templatizing the template. And so we decided to wrap that with Ansible. And so Ansible's great because it's agentless. You don't have, unlike Chef and Puppet, you don't have to have an actual agent that lives on the host itself to run it. And it allowed us to basically kind of templatize our CloudFormations. We took variables and made all these the machine names, the routing layer, everything's reusable. So you're minimizing the number of actual individual CloudFormations that you have to be specific to that specific code that you're running. And then to wrap it all together, we're using TeamCity. So many of you have probably heard of Jenkins. TeamCity is what we're using for our deployment and continuous deployment, continuous integration. So it runs all our tests. It runs, actually is hooked up into our GitHub directly. So on every developer commit, we run through our whole slew of tests against that code, and you get that on demand as developers are committing code. And so we know that our code that we're deploying up is tested, and the packages that go up into our production system already kind of automatically go through this whole system. So now, right, we are completely limiting what we can do, and we gain so much visibility with all the infrastructure as code directly. So what do you think, Brian? What else do you need from me?
Thank you, Zhen. Refreshing to hear how quickly we were able to actually do the maintaining visibility piece, right? Infrastructure as code. That concept, amazing. For CISOs, the fact that we could actually roll out things hardened already, right? It eliminates a lot of that human element error or that misconfiguration step. And again, that's music to our ears. So the next thing that I wanted to talk about was access controls. I was like, Zhen, how are we going to get granular access controls within AWS? How are we going to get default minimal privilege, right? So me being the CISO, I don't need access to patient data. How are you going to guarantee that that's not going to happen as we migrate our users to start using AWS? The other thing that I wanted was complete visibility of administrative activities, right? So we have a lot of developers that have the ability to go into AWS and create these awesome products for our patients, but I wanted to see exactly what was going on. In the event that something happened, we could respond accordingly. And the last thing I wanted to do is I wanted to ensure that we maintained authentication tokens. So these were something that I said, Zhen, how are we going to accomplish this as we migrate over to AWS?
Another long list of challenges that our lovely CISO has given us. So we're going, with access controls, you want to have them be granular. You want to have them be as scoped down as possible for what you needed. That's the only way to really be secure. No God mode, right? Minimize the amount of God mode that you have. So at the base layer, we decided to go with VPC segmentation. So VPCs are obviously like kind of the equivalent of VLANs in your local systems. You want to make sure that your network access is cut off and siloed as much as possible. So we did this within our AWS environments, even within accounts themselves. So in the Amazon VPC system, we actually have many different VPCs. So we have a VPC for our sensitive patient data. We have a VPC for our kind of syncing, B2B syncing with our enterprise clients. We have a separate VPC for all our other stuff that is not related to patient data specifically. This allows pure segmentation of the functionality of what we have, and we restrict the access between these systems to make sure that we don't have patient data flowing outwards to a VPC. Right? We want to restrict how much control there is. And you can do that with ACLs at the VPC level. So this gave us the confidence that at least at the high level, it's locked down. And it's a little bit more granular. But what else? We also need access management. So within AWS, they have these access management tools that are kind of a suite of tools that work well together. And so we built on top of that. And so this is the security groups. These are your IAM rules. And these are your policies. So policies being the actual pieces that control what has permissions to what. IAM roles being kind of the high-level roles of what would map to what, and security groups being a level above that, which is a group of users or a group of roles together. So we leverage this for not only our individual users that are logging in and accessing the system, but we also leverage this for our service accounts, right? Our service accounts are restricted to whatever they actually need access to. It's typically only one thing per service account. That way, you don't have a master service account that's accessing all your different services and has access to everything. Again, trying to prevent that God mode. It also allows us to have very clear rules around, OK, here's a security group. This is its role. And this is what you belong to in that security group. This is a great way to group and more easily track your access as well. So access management handles kind of who has access to what has access to what in combination with VPCs. But how do you make sure that the users are secure and that the things that you're making and making they're available are secure? So this is where the policy control comes in, right? We want to make sure that end users logging into the AWS service control system when they're going to the main dashboard that on login that they have to have MFA, right? That's super important. You can't just have a single, especially the root user account, right? But enforce it across the board. So we check and make sure that all our users have MFA enabled. Any users that sign on actually have to have MFA in order to access the system. As well, we check and audit to make sure that there's no public endpoints available that aren't supposed to be publicly available, right? Limit your edge. Scope down what has access to what on the public side, not just internally. And encryption checks. Make sure that everything is encrypted end to end. So we'll talk about that a little bit more later. But for encryption checks, this is mainly to make sure that everything that in transit is encrypted as well. So we're not just purely doing typical HTTP across our different VPCs or services. Even within the VPCs themselves, everything is HTTPS, so we can make sure that there's encryption in place. So speaking of encryption, I believe you have more encryption requirements for me.
Thank you, Zhen. And I do have more encryption requirements. So the next thing I wanted to focus on was data protection, right? I wanted to ensure that all of our patient data, our sensitive data, was encrypted, and that when we migrated it, we maintained that encryption over at AWS. So I wanted to focus on data protection. I wanted to maintain end-to-end encryption, so not just at rest, but in transit as well. How are we going to accomplish this? The other thing I wanted was centralized key management. I did not want keys in different instances, in different availability zones, and no management of it, right? I wanted to be able to have that visibility of the keys. The other thing that I wanted to ensure that we had was appropriate key rotation. I did not want a set it and forget it approach to our keys, right? So I wanted to know how we were going to do this, how we were going to accomplish it during the migration. And the last thing was restricted access to keys. Again, me being the CISO, I should not have access to these keys. So how are we going to accomplish that within our AWS environment? Zhen?
This is a lot to ask for, right? And we did this all in a year. So how were we able to achieve that in only a year with all these asks from Brian, our CISO? Honestly, the real trick here is that AWS does provide a lot of stuff out of the box, and we're able to leverage that on top of other technologies. And so what does data security at rest mean to us? It means that we're segmenting our keys across all our different AWS services. There's no master key to rule them all. We don't use a single key that encrypts all individual EBS volumes or S3 buckets. Within KMS, we're actually able to leverage that system to generate keys for us to encrypt every single component individually. KMS also comes with key rotation built in for you, so we don't have to worry about building our own key rotation system. This allows us to encrypt all our Amazon S3 buckets, as well all our EBS volumes, which we have a ton of. But that's not all, right? That handles our kind of data security at rest. Those pieces are built in by AWS. But what about secrets? What about passwords to third parties that we need to connect to, or third-party either vendors or kind of enterprise clients, or different things that we need to have access to that aren't just data at rest potentially? That's where HashiCorp Vault comes in. So we built a Vault system, a cluster, and what this allows us to do is basically have secrets managed in one place. Beyond just KMS. And Vault is more powerful than KMS for our use case because it allows leases of the security credentials that you have. So you have audits built in, you have new dynamic secrets that can be generated on the fly and have a time limit associated with it. So with this technology, our goal is to be able to say, okay, if you're a developer, you want access to debug something in production, instead of you having a permanent account that has access to this specific security group, instead, we can dynamically provision you something. You have to request kind of permission and approval for it automatically through the Vault system. Someone from our site reliability team will say like, okay, that's a legitimate use case. We'll approve it for X amount of time. That way we know that there's limited access for a limited period of time. And again, that's reducing that scope, right? Reducing that access level. So the problem with Vault is it's a software-based system. So it doesn't satisfy our kind of policy requirements that Brian brought up before. And that's where AWS's Cloud HSM comes in. So we're actually currently looking into integrating Cloud HSM with our HashiCorp Vault system so that we have a HSM hardware appliance that's going to secure our Vault system. These two systems actually work very well together, and it's even something that HashiCorp Vault recommends for those of you who need to be FIPS compliant. And it's basically our overall solution to have that work together. So that kind of handles our security at rest and security in transit solution. Now that we have things that are encrypted, HTTPS like everywhere, even inside the VPCs, as well as having all our data encrypted, right, at individual levels. So this is a lot of work, but Brian keeps giving me more stuff. So what else?
Thank you, Zhen. So the next requirement that I had given Zhen was enhanced logging and monitoring, right? I wanted to be able to have DDoS protection and front-end alerting when we migrated our entire platform. DDoS protection is very important for us, right? We have so many patients that visit us. I did not want to get hit and have our site take any impact or impact our patients, right? So I wanted to know how we were going to migrate that over. Next thing was I wanted detective controls throughout the entire tech stack. And every single server or instance, I wanted to know what was going on, and I wanted to have the visibility into it. Next, centralized logging. Right? Again, I'm harping on centralized logging because in the event that something does happen, or when it does happen, you're going to those logs to figure it out, right? So I wanted to be able to have that as well as during the migration. And last, I wanted office to cloud environment visibility, right? I wanted to see what our devs were doing while they were going over to the cloud. And it's not so much that we're not trusting our devs, but in the event that their machine locally gets compromised or something like that, I want to have that visibility to be able to react accordingly and be able to stop that threat. So Zhen?
So as Brian mentioned before, we have a partnership with AWS. And one of the reasons that we partner with AWS is because they have a lot of similar values that we do. And one of the things that they are really proud of is providing services so we don't have to do undifferentiated heavy lifting. And so kind of taking that model, we decided to take that upon ourselves too. So when we're protecting ourselves, we don't want to do any undifferentiated heavy lifting either, right? We're not necessarily good at all the different things that we need to do to protect ourselves. So this is where we brought in the big guns, right? We got help. And so when we're talking about DDoS protection, how do we protect ourselves? I mean, Zocdoc's not going to be able to be a network provider and protect ourselves, right? That's just not feasible. So instead, we worked with Infras, which provides Encapsula, and this provides our DDoS protection at the edge. So all our edges get protected by Encapsula, which allows us to not have to worry about DDoS attack, and they have a ton of bandwidth to obviously handle anything. But they also provide a WAF. So even though on our code, we're very secure and make sure that we don't have SQL injection vulnerabilities or cross-site scripting or the common attacks in your OWASP top 10, having a WAF is still good, right? Because you can never be too secure. You want to make sure you have those added protections in place. So that being at the edge means that we don't even see those SQL injection attacks. We don't even see those cross-site scripting attempts because Encapsula just protects us already at the edge. So the traffic never even hits our servers. But what else? Need data visibility. So this is the centralized logging aspect. I think I can hint that for you, Brian. We're using open source, the Elk stack, right? So that's Elastic, Kibana, and Logstash, right? So this allows us to have a centralized place where we can get all our data, all our logs, application, server, network devices, anything that you need. And it all goes into one place, so it's easily searchable, easily correlatable. And if you have an incident or outage or even just application errors, you can go and search it and find out what it is. So this gives us a lot of visibility into what's going on with our systems. Now, the problem with the Elk system is it's kind of text data, right? So text data is great, but it's kind of more reactive sometimes, unless you have some fancy machine learning system, which are available. So we have a SIM instead. So these are Alien Vault is what we leverage. They provide us that insight into the security incidents that may happen from the logs. So we send all our syslogs into Alien Vault. It's kind of like a fork from our centralized logging system. And so Alien Vault provides us that extra security and monitoring with the centralized pane of glass for if there's a security incident on the actual individual servers themselves, right? So not only do we have host-based intrusion detection that's on the kind of hardened image and antivirus, but you have an additional system to make sure that you can see what's going on just in case other things don't catch it. And then metrics monitoring. Text monitoring is not complete because those are only just logs. Logs are typically more reactive. There's just too much data for you to live react to it. So we use metrics monitoring heavily, both for obviously the performance of our individual clusters and hardware, but also for application metrics. How are we doing? How's the site performing? Is that affecting our downtime or functionality of our users? So this way, we can react very quickly if, let's say, the number of people booking appointments on Zocdoc is lower. We can see anomalies in that. We know exactly what the traffic is supposed to be and see if there's large deviations in that traffic. So this alerts us before we even know necessarily from the log system or the SIM, if it's not even like an attack, we know what's going on even from just potentially anomalous data there. And then when we're talking about security from the office layer, right, we also have to be very careful because employees are probably the largest vector for attack when you think about a security perspective. There's a lot of human error. There's a lot of phishing going on these days. And so we leveraged Palo Alto networks to upgrade all our firewalls. And what this allowed us to do is to get data visibility beyond just your typical layer 3 and layer 4 protections of, oh, here's a typical port-to-port or endpoint-to-endpoint protection, and I'm going to kind of firewall that off. No, instead now we can build rules within our data to inspect our data. So an example of that is we can create a kind of guideline for social security numbers. Anytime you see a social security number passing through our network in our corporate office, it just gets blocked. So if you're trying to send an email that potentially has sensitive data in it by mistake, it gets blocked and flagged and automatically goes to our InfoSec department. That way we can control that security and make sure that we're more secure. But my team's not doing all of this by ourselves, too. InfoSec team's helping out, too. So they have individual contributors who are also making sure that we're, again, being more proactive. You can never have more security. It's just an arms race against what you can do. So for us, we used Qualys and Fortify to make sure we're doing vulnerability scanning on our code. So Qualys does that vulnerability scanning, right? It looks for places where potentially we have an open network or kind of something that's open and accessible in our code, in our test environment. Fortify as well is part of our actual test cycle where we do static code analysis for all our code. So not only do we now have testing, right, your typical unit tests, integration tests, we also have some tests in production, but now we have static code analysis as part of our continuous integration cycle so that we can, again, feel more secure and just know that we have all these controls in place to help protect us. But again, it's never enough. So there's still more to do, Brian.
Still more to do. Yes. Thank you, Zhen. So we were talking about protecting our environment and using Qualys and Fortify. Qualys and Fortify give us that data that we could actually be a lot more proactive with it, right? So we see it, we'll be able to deliver it to the teams, and actually they could remediate. Fortify does it to an extent that the devs don't even feel that they're actually being scanned. They just get those reports and say, this is something that it found and they can action on it. It just makes it a lot more seamless for our devs within the life cycle of developing code that doesn't slow them down. It's one thing that we did not want to do, right? Putting in all these controls or putting in all this visibility, we did not want to slow down our development team, right? So it was very important for us in a feature. But the next thing we were going to talk about was incident response and disaster recovery, right? I am a CISO, so I'm always thinking about that incident, when it's going to happen, how are we going to respond to it. So I wanted to actually meet or exceed our existing SLAs that we had when we were on-prem. How are we going to do this, right? I don't have a data center to go to. How are we going to be able to actually respond to this, right? I wanted to be able to do pen tests and tabletop exercises well in AWS, right? Zocdoc, we welcome the opportunity to being judged. We do 3 pen tests a year by outside firms. One of them actually being a black box test, which we don't really give, no one really actually even knows about it, including the security team. So when it happens, we get the results 4 weeks after it starts, and we know where we're at with it, right? But I wanted to be able to still do that well in AWS. I also wanted to do tabletop exercises, right? And working with Zhen's team to say, this is a scenario, how are we going to do it? How are we going to do it while we're in AWS? Can our solutions architect in AWS be part of that tabletop exercise, right? I wanted to be able to do that. The last thing was environment resiliency. I wanted to be able to recover the environment in the event that something happened from a disaster recovery perspective. I wanted to meet or exceed our existing SLAs. So I asked Zhen, how are we going to do this now that we're migrating completely over to AWS?
Oh, so this is actually my favorite part of this presentation. That's because within AWS, all your resources are very elastic. So I'm sure some of you have experience managing a data center. And so what happens when hardware goes down in a data center? Well, you have to go and replace it, or you have a lot of redundant hardware in place, which is very expensive from a CapEx perspective. So how do we respond to respond to disaster recovery incidents, right? We actually took our migration to AWS as an example of what would happen if we were to lose our data center, right? How would we, in a disaster, fail over to AWS and use that as our migration plan for even getting there in the first place? And so what we did was we actually made AWS our active disaster recovery site initially. And that was the initial build. And when we did the actual migration, it was just, hey, let's test our disaster recovery system and see how it fails over. And it failed over with no downtime whatsoever. And so that's how we were able to get over so quickly. Not only that, with remediating penetration tests, right, we want to make sure that that's a high priority. We have 3 penetrations externally a year. So that means that we need to make sure that our teams are in sync, that the timing aligns, and that when the penetration test happens, we get the report and we react very quickly with very, very tight SLAs to make sure those highs and criticals are addressed right away, obviously with the criticals being higher priority. So we were able to achieve that with an average kind of resolve rate of all our criticals and highs within 2 weeks, because that is our highest priority to do, and everything else stops in order to do that. Collaborative tabletop exercises. So we're able to decide to plan out kind of what could potentially happen in a disaster scenario. And we come up with cases together on, in this event that this happens, how do we handle it? And not only do we do that just internally, right? You want to involve your third-party partners as well. So we involve AWS, and we talk to our solutions architect and explain, like, in the event of AWS outage, S3 outage being in February, right? How do we handle the situation? What are your expectations for how do you handle that outage? And how can we better handle it? And so we actually walk through that exercise and think about, OK, if it were to happen to us right now, what does it affect? And how do we address it? And how do we do better next time? And we're constantly coming up with scenarios to walk through those things. And that actually helps dictate our roadmap going forward. And of course, having an active disaster recovery site is an all. Right? In order to have a disaster recovery site, you have to have data somehow go asynchronously, typically to another region. So what we do also is have a live active backup for our data inside the existing region in a different availability zone. So we have multiple backups going out. And this is great because it's like a replication, live replication. You have completely synchronous writes to a completely different AZ. And this is extremely helpful for, we found after we migrated that your EBS volumes can randomly have a performance hit because they decide to migrate in the background, completely unknown to you, that is going to go to a completely new EBS volume, and they want to initialize it, AWS that is, which has a huge I/O performance hit on your EBS volumes. So if that affects our main database system, guess what? That's going to cause our clients. That's going to impact our clients because that response time is going to be significantly slower. So what we have as a solution that we built in without knowing that this was a problem was we could fail over our databases instantaneously to another availability zone in case that happens. So now that EBS volume migration has to happen to multiple availability zones, to multiple EC2 units on those availability zones. And we can fail back over in case there's any issues. So we have a live replica in multiple AZs. But we also have a replica in another region. So we have US East 2, Ohio, as our disaster recovery region. So our data actually makes it there also within seconds, typically 4 to 5 seconds. So we have live data replicating across multiple places. In case of failure, we can recover all the data with really minimal data loss. Now, the biggest problem with that is now that we have this kind of live replicating system, it's fairly live. So even if it wasn't live, let's say it's like 2 hours delayed, That still means you only have a 2-hour window in case your data gets overwritten or someone accidentally made a mistake and ran some code that completely changed some data that you wanted to preserve. And this is where our backups are really, really important. So we have a very, very egregious and timely backup system that goes through and backs up all our data on a very 10-minute window kind of frequency. And ships it off encrypted into S3 regions, right? And then S3 allows us to automatically replicate that to another region. So now our data is also backed up. We can restore a point in time if we need to, and don't have to worry about as much in case of data being overwritten. We also have that recoverability if we need it. So now you have kind of multiple ways to recover. So let's talk about a little bit more about our failover mechanism. How do we even get into AWS, as I mentioned, with like pretty much no downtime? When I say no downtime, I mean like we're talking about 10 to 20 seconds of the actual, from data center to AWS swap. So we call this a ramp up, right? It's similar to what you would see in like blue-green deployment. We took the very same concepts and decided to apply it to our data center to cloud strategy. So what we did was we completely built a new environment in AWS. Of course, you have to start with that. But we took our existing kind of monolithic systems and we spun it up in AWS, but a smaller footprint to start, right? And a key piece of this is we got a direct connect between our data center and AWS USC's Virginia region. So that direct connect provided sub-20 millisecond latencies between our data center and AWS. So this allowed us to basically treat it as one network, pretty much. And so when we built up the new system, what we did was, with this, the smaller pieces to start, we had a database replicating over, we had the web servers replicating over. We decided, OK, let's just fork some traffic over. So we did a slow ramp up, right? 1% of traffic, 5% of traffic, 10% of traffic, and watching the error rates within Amazon to see, did we do this right? And of course, everything that was built on Amazon was hard AMIs, infrastructure as code. Everything was repeatable. So once we gained confidence, we could just immediately ramp up our web server builds and basically build a much larger fleet within AWS than our data center. So now, all your traffic is going to AWS, but our data is still being written into the data center. And this is where our failover takes place, right? So we do our actual data transfer over into AWS. And since it's actually live replicating, we changed it from async mode to sync mode, and all the data writes were consistently moved over, and we made AWS our new primary. And so that blip was very much like basically 20 seconds in order to make that move. So AWS became our new active, and we could fail over and fail back at any point of time. So we actually leveraged this same strategy now that we're completing AWS, right, as I mentioned, to replicate to our US East 2 region as well. So now we have the same kind of failover mechanism we can leverage if we need it, even though we're completely in AWS, and we've already tested it multiple times. So with all these things, how have we achieved our kind of AWS goals? Scale horizontally? Absolutely. We have infrastructure as code. We have hard AMIs. We can spin things up with the press of a button. We even have auto scale for some of our pieces. Our CI environment, thanks to our DevTools team, was able to spin up completely automatically depending on usage, right? And they'll test automatically based on the number of dev commits. It's completely auto scale based on how much the devs are committing. And we're leveraging spot instances to make sure that's actually cheaper. Diversify our tech stack. We've been able to achieve that as well. We've been able to leverage the container ecosystem, and now we're host to many other languages besides our initial Microsoft kind of based shop. We have Node.js, we have Scala, we have a lot of different, we have Python. There's just so many different ways that we can now run within AWS, which is supported already within AWS. Open source. We've already spoken about a lot of open source technologies we've used, such as the HashiCorp Vault, Elk. All these technologies are things that are already supported by a vast community. And we've leveraged that, right, on top of the AWS tools to get to where we're going. And then data liberation. So kind of Werner talked about this a little bit during his keynote today, but we're leveraging AWS serverless to get our data freed from our database systems to be able to be accessed via streams and via Lambdas, so we can get it into and be consumed in many different places, really. And of course, the focus of this talk, we elevated our security, right? Through all these different layers that we discussed, we were able to make sure our security posture was stronger within AWS than it even was in our data center. And so, what are your key takeaways here, Brian?
Thank you, Zhen. So I see a few of the key takeaways are when you're migrating to AWS or you're there, look, take advantage of the available security controls that are there, right? There are so many security services that AWS offers. Do your diligence, do your research, see how it applies to your tech stack, how it applies to your organization, how you can apply it within your platform. There are so many, and they put out new services, very, very quickly. Next thing was we were able to simplify security and compliance. The fact that I'm able to have containers spin out hardened devices with already having host space and AV. I mean, compared to how it was, months ago or years ago when you had to, rack and stack a server and actually load the application on top of it, to be able to do it in minutes versus days, right? That's a huge, huge shift for us, right? The other thing was, with AWS, you have enhanced visibility and control. We have complete visibility of our entire stack, plus all the data flowing through it, right? Not having that visibility opens you up to a lot of risk because you don't know where you need to respond to an incident, but now we actually have that visibility. So the other thing is faster security recovery and delivery. How Zhen was able to just explain the quickness of failover, the quickness to actually do disaster recovery. How many of you guys remember when you had a failover between data centers? Right? You're talking hours, days. Now we can do it within minutes, right? That is a huge shift and allows us to focus more on developing products to help our patients instead of focusing on maintaining archaic architecture, right? But I think the key takeaway that you need here is get yourself a squad. Get yourself those partnerships within AWS, right? That we were able to get that solution architect to help us do that. We chose AWS because of our shared principles, right? Rapid product innovation and customer obsession, right? Get yourself a squad that does that, but also internally. I mean, the partnership that Zhen and I have to actually do this and maintain it, because this is not just a set it and forget it. We want to continually evolve and continually, push our products out there quicker, and we need this partnership internally. So if you're thinking about a migration or you're there, just have those partnerships because it makes things go a lot smoother. So I'm going to turn it over to Zhen, who's going to close it out.
Speaking of squads, Zocdoc is hiring. We have many squads that you can join, so definitely check us out. Another key point that Brian was saying, security is a piece of all of us, right? It's a culture that you have to live. You can't just silo it down to the InfoSec team. I know we talked about it a little bit during the keynote today, but it's really something that everybody has to live and feel within the company. Down from your salesperson, your operations person, human element is kind of the most riskiest vector for attack. So you want to make sure that your whole organization is aware of it and that everybody feels that security posture so that they know to speak up when they see something that's outside the ordinary. And so we're able to leverage that. And our internal teams are all aware. We have very strong security training. And so we feel like we're part of a larger squad overall at Zocdoc that's very security focused. Thank you all for your time. We have some time to take some questions. So there's some mics up here. Do you mind coming up to the mic?
How big is your is there a team? Is there a DevSecOps team that built all of this, and what's the head count?
Yeah, great question. So yes, we do have a DevSecOps team, the site reliability team. So overall, to do the migration into AWS, we had a core group of 8 people who did it over a 6-month period.
And is that the sort of same team that's doing the product development for the Zocdoc, web app and plumbing and all that to communicate with your API partners?
No. So we have separated infrastructure and product teams. So the product team continued to build we knew we were going to the cloud. So the product team focused on building containers and actually moving forward that way, while our infrastructure teams focused on building a way for them to kind of maintain those containers while also migrating to the cloud. So we actually did the container piece first, and that's part of our 2-year journey. So the first year was kind of get the new architecture ready, and the second year was let's move all in.
Got another one here.
Are you guys using encrypted root volumes or?
Yes, encrypted EBS volumes.
Root volumes.
Root volumes.
Yeah.
So we're using encrypted S3 and EBS volumes. I'm not sure what you mean by root volumes.
Because when the instance comes up, right, it has a root volume.
For the
Yeah.
root volume.
Because if you want to encrypt it, you have to make a separate AMI out of it,
Right, right.
right?
So currently, we don't have encrypted root volumes yet.
Okay.
But we do plan to implement that because we're constantly trying to elevate our security posture.
Okay. And next, another question. Sorry, go ahead. You want to go ahead? Yeah, you said you have HTTPS everywhere within the VPC. How do you verify that an application is not sending HTTP traffic?
We have monitoring in place, right? We can see the traffic flow within our environment, so we make sure that all our endpoints are HTTPS only.
What monitoring?
So the way to do it is at each of our endpoints, we can see what the requests, how they're being made. And so as part of the scanning, we can see like what protocols are being allowed.
Okay, thank you.
Like you can see what ports are available, right? Like port 80 versus HTTPS.
Port 3, yeah.
Yeah, hi. So for your infrastructure as code and your app code, I imagine, I think you said you have it in a GitHub.
Yeah.
How do you make that persistent between your on-prem and your cloud? What mechanism do you use to keep that both versions in sync?
Yeah. So the question is, how do we keep our kind of code base for infrastructure as code in sync with what's actually live in production? The key is to deploy frequently, honestly, right? We deploy multiple times a day, and we only deploy via the infrastructure as code. So even if someone makes a change, like the nice thing about CloudFormation is it can't actually detect differences. So only make that change that's a diff for most things. Some things we learned the hard way that actually restarts your whole system. So we have made mistakes like that before as well.
Just a clarifying question. It was more about disaster recovery capabilities of your code itself. So how do you make your GitHub persistent between AWS and your out of region or your on-prem potentially?
Oh, I see. So our GitHub solution, we're actually using GitHub as the SaaS service. So it's not internally hosted. We use their enterprise solution in the cloud. So it's actually accessible everywhere. It's not just the self-hosted GitHub.
I have two questions. The first one is you mentioned one of the goals is to control the least privileged accounts. I want to know whether you have any tips to set up those accounts and have a limit authority, and how you design this model to say that's the right authority you should have.
That's a really good question. So it's definitely very challenging to start, right? How do you know what people want before you've even used the system? So you start out looser, and then you kind of cut down access over time. So we started with pretty much my whole SRE team having God mode, and a lot of developers having God mode as well. And then over time, we evolved and learned, OK, well, these are the actual permissions that you need. And we started restricting down to what people had. And in prod, we always restricted access so that developers didn't have access. They actually had to come to the site reliability team to debug and figure out things.
Gotcha. Second question, I see you guys already done a lot of things on security. Just curious, what is your next step? Like, what's the next thing you plan to do?
Good question. So there's still a lot in progress. One of the next things that we want to do from a security perspective is make sure that our centralized logging is something that we can continue to iterate on. Like what I was mentioning before, centralized logging by itself is nice that you can reactively go in, but it'd be nice if we could proactively gain insights from it, right? If we could proactively figure out, oh, something's wrong, or make that more scalable and having more people dump logs into it. That's very powerful to use now that the system is there. Brian, I don't know if you had any.
So aside from that, right, so getting some of those logs and maybe then creating like a Lambda function that if it finds something actually goes and fixes or kills a process or does something like that. So we're going to start looking at that. The other areas we mentioned, kind of like Palo Alto from the office to our AWS environment, but we're also going to look at next gen within AWS, right? Can we actually look at the data and even break encryption within the data and say, hey, is there something going on in here? We're going to start evaluating that in 2018 and see if it's something we could leverage.
Gotcha. Thank you.
Mm-hmm.
Hey, I have two questions. So the first one is, why did you guys use KMS over console, since console has seamless integration with Vault, right? And the second is like where do you store, like do you encrypt the master key for Vault and where do you store it?
Yeah, so for console, we did actually look into console as well. And we tested out console and had that build up as well. I mean, console is more of a, similar to Vault. It is also a secret management system. So it felt like Vault and console were a little bit redundant, except Vault had more capabilities. KMS is just directly built into AWS. So there's not a built-in support for EBS volumes and S3. You just directly integrate with that. So that was specifically what our KMS usage ended up being. For the second question, it was, sorry, can you remind me what the second question was?
So Vault has a master key.
Oh, sorry, yeah, master key. So master key for Vault, that's where the cloud HSM comes in, right? So we have a hardware appliance that's going to contain and unlock with that master key.
Okay, so you encrypt that and store it there?
Yes, within the cloud HSM.
Yeah, just interesting about just interesting about the end-to-end secure encryption. So let's say you have an application outside AWS, then talk to one instance inside the subnet of the VPC. How you ever guarantee, to end-to-end security? Because the ERB load balance, we're going to decrypt. So how you guarantee the end-to-end? Also, the segment key. How you able to generate segment key between two instances within the AWS VPC?
Sorry, the first question, let me see if I can.
So end-to-end security, encryption. So
how do we maintain end-to-end
exactly.
encryption?
Yeah.
So when we designed it, we made sure that everything was SSL, start to end. So we encrypted the traffic and how that endpoint is.
So the load balancer does not decrypt the SSL at all?
I'm sorry?
The load balancer, you have a load balancer in the entrance, right?
Right.
So the load balancer does not do the decoding for the traffic?
Oh,
They
I see what
just
you're
let it pass through?
So we are using ELB, but you are able to encrypt between ELB.
What he's trying to say is, do you terminate SSL on ELB and then re-encrypt?
No. So we terminate at the actual node.
Oh, okay. So ERB does not do anything, just pass through.
No, it only does the actual
Okay. Gotcha.
endpoint that it's where it's
So what about
routed to.
the point-to-point, instant-to-instant?
Yes, we do not decrypt at the ELB level.
Okay, so between two instants, you also have a shared key?
Correct. Yes.
Okay, thank you.
Hi.
Hi.
Can you speak to any cultural or development process challenges that you and the larger development team faced as you made the transition between environments?
Yeah, there's many. Where do we start?
What are the biggest ones, I guess?
Biggest ones. I think the biggest ones is, I think the biggest one by far is the operations culture, the DevOps cultural difference, right? We historically had a strong site reliability team, and they took on the brunt of that, especially when we had a monolith. So they managed the whole deployment, as well as any incidents that may come up. They're the first ones to get notified in case anything went wrong. As we moved out into AWS, we started to want to move faster, right? So each team started owning their own pieces, and they had to learn the operational pieces themselves. And so that was definitely a large cultural shift for them, that they had to understand, okay, well, how do I prevent outages myself? How do I build my apps? Yeah, they knew that we had to load balance and do blue-green deployments that have multiple containers, but they weren't sure necessarily how to monitor performance, or how do I design for something that's scalable or redundant or has failover.
Thank you.
I have a couple of questions. One is regarding, so when you mentioned about containerization using Docker, so you mentioned the hardening of the host and hardening of Docker itself, and then whatever you are running inside Docker. So can you can you explain a little bit more on that? And also, how are you doing any vulnerability assessment in the container, for container?
Good question.
Great question.
So that's actually something that's something we were looking into as well, which is within the container itself, how do you maintain security? How do you make sure that there's no vulnerabilities within the container that you've now released? So there's actually a couple open source technologies that we're currently investigating, as well as paid solutions, to see how do we lock down the individual containers that are deploying besides just the host. I mean, we know that we're comfortable that like anything that's being deployed into here is being tested and is run through our testing system, which has the code, like static code analysis as well as the vulnerability scanning. But it's like, how do we live make sure that there's that intrusion detection, kind of malware protection on the individual containers? And there are solutions to that which we're looking into right now.
That's great. So one of the things is you have GitLab as or GitHub as your container registry. Mm-hmm. Is that correct?
Container registry. So we're using ProGet, like NuGet packages. We actually have a bunch of different package systems, so that's something we can improve a little bit, which is centralize our package systems. But we use like a package manager.
So how do we make sure that, how do you scan at least the image part before, forget about the runtime protection, right? Runtime protection, you covered it already, that okay, you're looking into. But how do we make sure that image itself, which is in registry, and before it goes to registry, it is obviously it's part of CI/CD, and make sure that it is tested, etc. But then the image which is going to be used by going inside production or going to push into production is the one which is certified.
Right. So our container registry makes sure that it is the same package that gets replicated from our different environments. But you're right. So like we do need that additional kind of scanning operation on the source package itself to make sure that's secure.
You're not doing any scanning on the registry right now?
Not yet.
Okay, good. Okay, got it.
Great. Looks like we're out of time. So thank you all for
Thank you for your time. Have a good one.